Alright, let's go through this here. So this first one here is correct using the angle addition postulate. I discussed this last time. A whole is the sum of its parts, and all this is saying is the entire angle SRO is equal to MRS plus MRO. So it's just saying the whole is equal to the parts added to each other, added together. The second one is a little bit tricky because of the list of theorems that are given in the module. So I'm going to kind of explain what's going on here. So they want us to justify the statement that the measure of angle MRO plus measure of angle MRS is equal to 180 degrees. Now, two ways of concluding the statement, and when I say concluding the statement, I mean of drawing this statement from some previous statement. That's what I mean by concluding this statement. Two ways of getting to this point. First one is using the definition of supplementary angles. So if you already know that two angles are supplementary, then you can apply the definition of supplementary angles to conclude that their sum, the sum of the measures, is 180 degrees. Another way of concluding this statement is using something called the linear pair theorem. Okay, so linear pair theorem just states that if you have two angles that form a linear pair, and before I finish that, let me talk about what a linear pair means. Linear pair looks like that. So two angles that form a linear pair, it means that they're adjacent first of all, and so these two angles are adjacent, meaning they're next to each other, and they form a straight line. That's where we get the word linear from. So these two angles are adjacent, they form a straight line, so it's a linear pair. So again, I know this is a little bit, there's some subtleties here that we need to pay attention to. First of all, we can't say that we're using the right angles theorem. Why not? Because the right angles theorem specifically says that right angles are congruent to each other. That's what it says. Now, we already know that the two angles are congruent to each other. We come back over here, it gives you the given. It's saying angle MRS is congruent to angle MRO. We already know that. So we don't have to use the right angles theorem, because the right angles theorem would tell us that if the angles are right angles, then we'd know they're congruent to each other. So we can't use that here because we already know they're congruent. We don't need to justify a statement. We don't need to justify the statement that they are congruent. We know that already. What we need to justify is the statement that the sum of the two angles is 180. So like I previously said, there are basically two ways of doing this. So one of them is to use a simple definition of supplementary angles, which I believe is the safer one in this one to use. We can send an email just to confirm that, but this is a safer one to use because, now you might be wondering why is there some skepticism? Well, because we have to already know that the two angles are supplementary, but we don't really have anything before this question that concludes that they're supplementary. And it would not be correct to just look at the picture and say, oh look, you know, they look supplementary. We can't just do that. At some point we have to know somewhere that they're supplementary. And once we know that they're supplementary, then we can use the definition to conclude that the sum of the measures of the supplements is 180. So I think that's a safer one to use, but I like to be very systematic and meticulous, so I might be reading too much into this, but this one is the safer one to use. Now you might be wondering, why is this a safer one than the other one? Well, the reason why is the linear pair theorem is actually not on the theorem list. They put it in the conjectures list, and they don't even call it linear pair theorem. They call it linear pair conjecture. You might be wondering, what's the problem with that? Well, the problem is you can't use a conjecture to justify a statement in a proof, because by definition a conjecture is a statement that hasn't been proven yet. That's what a conjecture means. So I find it odd that they would put the linear pair as a conjecture, instead of a theorem. That's I don't know, it's just kind of interesting. I'm gonna play it safe here and say that we're not going to use the linear pair theorem because it's not specifically in the theorem list. It's in the conjecture list, and again, technically you can't use a conjecture as a justification in a proof because a conjecture itself hasn't been proven. Now you might be asking me, or you might be wondering, what's the difference, or what's the point? Well, it's really not correct to call it the linear pair conjecture because it actually has been proven. So once a statement is proven, then it's not a conjecture anymore, it's a theorem, right? That's what makes something a theorem instead of a conjecture. So conjecture is just like an educated guess. And there's no way that you can use educated guesses in your justifications of proofs, right? Can't do that. So I'm gonna hazard here to say you probably shouldn't use this, even though if you look online or get another geometry book or something, you will see linear pair theorem and it being used in justifications, or in justifications of proofs, inside proofs, right? So here I'm gonna go ahead and go with this, and I mean there's just a minor risk, so I would like to ask the greater question about us being able to use the definition of supplementary angles. It's when this was designed, it's a little bit sloppy, I think. So I apologize for kind of the subtleties here, because it's a little bit sloppy. So I mean that's okay. That was the only one that's kind of sloppy. But anyhow, we can go ahead and move to the third one. This one's pretty clear. So in the third one, again, we're given that angle MRS is congruent to angle MRO. We already know that. So since we already know that, it's actually pretty simple to go from here to this statement that says that their measures are equal. That is just the definition of congruence. In parentheses I put for angles. Technically, if you want to be ultra precise, you have to specify definition of congruence, congruent angles, let's say. But in the modules, they don't seem to be very systematic about that. So if you just leave it as definition of congruence, that's acceptable. That's fine. And again, I wrote out the actual definition of congruent angles here. So it says if angle 1 is congruent to angle 2, then measure of angle 1 equals measure of angle 2. And if measure of angle 1 equals measure of angle 2, then angle 1 is congruent to angle 2. You might be wondering why I put two conditional statements here, and I used the word and. I use that word and. Why did I do that? Because remember, biconditional statements are just conjuncts of conditional statements, right? So let me go ahead and scoot the paper here so you can kind of just see that on the side. This is not part of the answer or anything. This is just kind of explaining where that's coming from. So biconditional statement is P if and only if Q, which is logically congruent to the statement P implies Q and Q implies P. So whenever you see a biconditional statement, it just means that the original conditional statement and the converse are both true. Okay, so the nice part about the biconditional statement, and that's why we use it for definitions, is that you can go back and forth. So if you start with the two angles being congruent, then you can conclude their measures are the same. Or if you start with the measures of two angles being the same, then you can conclude the two angles are congruent. So it allows you to go back and forth here. That's kind of the convenience of having biconditional statements, which are definitions in math. So that's question 3. So let's go ahead and move on here to question 4. Where was it? Wait, did I print it out? Yeah, I was printing these out. Where was it? I feel like something got cut off here. Oh, it's on. Where is that? Oh, it's over here. I'm sorry. Okay. So now we can look at question 4. And this one is saying that the measure of segment SR plus the measure of segment RO equals the measure of segment SO. So let's look at that. We're saying this guy, this little part right here, plus this other little part equals the whole. The whole meaning the entire line segment. Again, this is one of those cases where we have the whole is the sum of its parts. Is the sum of its parts. Which means it's going to be one of our either angle addition postulate or segment addition postulate. This time we're dealing with segments, so we're using the segment addition postulate there. Okay, so that one's pretty straightforward. It's kind of like question 1 except segments. And then we can move on. Question 5 was correct. Good job on that. Reflexive property. That's when something is this is incorrect. I mean, you're right, but the question is incorrect. Look at this. I just I noticed a typo here. Why is there a typo? Because this is saying measure of VO is congruent to measure of VO. What's wrong in that? Congruence only applies in this context to geometric objects, right? This is a number, and this is a number. So these two are numbers. We can't say that two numbers are congruent in high school geometry. So it should really say segment VO is congruent to segment VO with a line on top. That's how it should be written. Yeah, so this is actually, like I said, I feel like this was kind of sloppy. This is, I don't know, it's kind of sloppy. I apologize for that, but anyway. Yeah, so some of these questions, I don't know, they could have been written way better than they are. So apologize on behalf of, geometry pedagogy. But anyway, all right, so that's that. So yeah, that's correct. Reflexive property. Good job. And then over here, question 6, that one was also correct. We just needed to add something at the very end. So let me pull up, where was it? It's over here. It's question 6. So what you wrote is correct. So that all of that is fine. The only thing you need to do is at the very end, it says here, and the given shows angle 1 is congruent to angle 2, making angle 3 congruent to angle 5 as well. The only way we could know that is by using the transitive property of congruence. Okay, well, you don't have to write of congruence, but you can just shorten it to the transitive property. But that's the only way that we could know. So that's a good, that was a good, nice little argument. I like that. That was well constructed. Very nice argument. The only thing here is that last little bit needs to be justified. So we have to use a transitive property there because we're saying 1 is congruent to 2. Where's that? 1 is congruent to 2, and then you're saying making 5 congruent to 3. So to make that jump there, you have to use a transitive property. All right. So that one was question number 6. Yeah. And then question 7 is the one where you have to fill in the proof. Here's the 2-column format for the proof. And let's kind of go through each step here. So again, the given is pretty basic here, just saying measure of angle LOM, that's over here, LOM, this little one, equals measure of angle JKI, which is over here, this little one, and MON, which is this one, equals IKH. Where's that? That's over here, IKH, this one. So pretty simple. That's given. It's stated up here. The next statement says measure of LOM, so that's over here, so that little one again, plus measure of MON. Notice in this statement they're adding something, right? I notice that you tend to get confused with the addition property of equality versus the segment addition property. Here they're actually constructing something, right? They're starting from just LOM, and then they're saying, hey, let's add MON, and then this is equal to, and then they did that to the other side of the equation. That's how they got measure of JKI plus measure of MON on this side. So they're using the addition property of equality. You might be wondering, since this is already written, I can actually You don't have to write this for the answer, but I'm actually going to go step by step in constructing that, so I feel like it'll make more sense if I do that. So really where they're starting is at this statement. Measure of angle LOM equals measure of angle JKI. JKI. So it's like you're starting here, and then you're adding the same thing to both sides of the equation, like in algebra, right? So this is, well, what are they adding? The measure of angle MON. Notice it appears on both sides of the equation. MON appears on both sides. So they're just adding it to both sides, that's all. That's why this one is the addition property of equality and not the angle, I'm sorry, the angle addition postulate there. Okay, next one says measure of angle LOM, so LOM, this little one, plus measure of angle MON, of this little one, equals measure of angle JKI, that's over here, plus measure of angle IKH. So you might be wondering, how in the world did they go from the previous statement to the next statement? Well, if you're looking at, here I'm like kind of rewriting that proof, right, the statements. If you kind of go back to this one over here, you'll notice that using our given, and we're using this particular one right here, measure of angle MON equals measure of angle IKH, they just substituted, that's all. So this part of the equation stayed the same. This stayed as measure of angle LOM plus measure of angle MON, that stays the same, equals, and then this one stays the same here also, measure of angle JKI. But instead of writing measure of angle MON, we substitute, and now we write measure of angle IKH. Okay, so that was just a simple substitution there. But I wanted you to see kind of like how these statements are connected, how they're going from one to the next and then to the following one, so on and so forth. So that one is for number 3. So the justification or the reason is substitution property of equality. We substituted measure of MON with measure of IKH. So we got that one. Now this one says measure of angle LOM plus measure of angle MON. So where's that? LOM plus MON equals measure of angle LON. Wait, sorry, I feel like I'm missing. Oh, they're putting two different statements here. The first one is LOM plus MON equals LON. Okay, so we're doing a little one here, that's a part, plus another part equals the whole. And whenever that happens, we have the angle addition postulate. And notice they do it twice, right? We get two statements here. The second one is measure of angle JKI, which is this little part plus this little part equals the whole thing. Okay, so that's angle addition postulate. And then finally, we have to use the transitive property of equality. Now you're probably wondering, why transitive property of equality? Well, if you look at the statement above, what you're trying to say here, what we want to conclude is that this one is equal to this one, right? That's what we want to show. And in order to conclude that this one is equal to this one, we've just argued that this one is equal to this one. So if these two are equal to each other, and they're both equal to these other things, then those other things are equal to each other. That's the transitive property. Okay, so that's where that comes from. So that's kind of a tricky one, but the idea is that we were just showing that this thing and this thing are equal to each other. They're the same, and since they're both equal to other things, then those other things are equal to each other, right? It's like saying A equals B, B equals C, therefore A equals C. Alright, you're saying that A and C are both equal to the same thing, so they're equal to each other. Again, so this guy and this guy are both equal to the same thing, so they're equal to each other. And that concludes this portion of the explanation.